All right, guys, so we are now heading into 1-8, solving compound inequalities. By the time we get done here, are going to be able to solve and graph different inequalities. So first off, you probably want to know what a compound inequality is. Well, a compound inequality consists of two distinct inequalities that are joined by the word and, or. So I know it's kind of like two words, or twice. But and or are indicative of things being combined. There being multiple parts of it. So like when we go to write a compound inequality, we want to be able to write an inequality here that is all real numbers that are greater than or equal to -4 and less than 6. So let's just, you can assign whatever variable you want for all real numbers, but give that a shot. All right, so greater than or equal to 4, I'm going to set up that some number is greater than or equal to a -4, but then it also has to be less than 6. So I could also write this as 6 being more than x. So now I could actually flip it around and write it in the correct numerical order. So I start with my lowest value, so -4, and if I flip everything, it'd be is less than or equal to x, but x is less than 6. So now x must fall into this range of -4 to +6. So now try b. All real numbers that are less than or equal to 2.5 or greater than 6. Now this or is going to make this different than the and. Alright, here's how we get into the meat of the difference between and or. So, or, I now have two separate inequalities that, if you notice, are essentially the same thing, while both telling me that x is greater than, scratch that. Both are different, but realize x is greater than 6, or x is less than or equal to 2.5. That's going to be disjointed when we go try to graph it. So if we come up here and graph the first inequality, let me get my pen back. So we start with -4. Now we have to decide, and hopefully you remember how we look at graphing and what sort of circle I'm going to use. So I have -4 as one point and a +6 as the other, and 0 is going to fall somewhere in between, closer to 4. So we always put circles around our points, but then we have to determine, how do I know whether it's open or closed? Well, if it has the equals, the -4 less than or equal to x, then because it could be equal, we close our circle, we shade it in. We're going to shade all of this. And then 6 is not a potential solution, so we do not shade 6. Down here, this graph is going to be different because we have 2.5 and we have 6. But now x could be less than or equal, so again I'm going to put my circle and I'm going to shade it because it's or equal, less than or equal, or x might be greater than 6. So because of that or, we have a disjointed graph, and because 6 is not an included point, we do not shade that circle in. Go ahead and try to figure out then, what do you think the difference between inclusive and x is between -5 and 7 and x is between -5 and 7 inclusive? What difference does that inclusive make? Alright, our difference here is that if -5 and -7 are inclusive, they are included points. So just make sure that you understand inclusive means included points. So, and is always going to have one graph that makes both inequalities true, and the or is going to have two different ones. So I want you to try and solve this and see what we end up getting. What, when we solve, is the range that y could fall in. Alright, so here's a huge difference when we go start trying to solve these inequalities. When I have two inequality symbols, like here and here, both of those kind of work as that imaginary dotted line where what I do on one side I have to do on the other. Well, now I have three locations where I have to do it. So I have a constant and a variable in the middle here. I want to get just the variable left, so I'm going to add 4 to get rid of this negative 4, and I do it all 3 of these locations. So make sure that you have that correct, and then keep trying to move on. All right, so now we will get on our left side here, 2 is less than 3y is less than 18. So now to get the y by itself, yeah, you guessed it, we just want to divide. And what do we divide by? Well, the coefficient of the y. So we divide by 3. That leaves me with a final answer of 2/3 is less than y is less than 6. So if we wanted to graph that, we could come over here. Could mark up our 2/3, our 6. 0 would be down here around our 2/3. We put circles around both points. Now, do we fill in the circles? If there's no equal sign, we do not fill them in. So y is bigger than 2/3, less than 6, which is why I can represent it by one double inequality and one shading of the graph. So there you go. Now, if we move on to this, try to solve this problem about grades right here is what we want to tackle next. So if you scored a 78, a 78, and a 79 on the first 3 tests in a course, and your last test is out of 100, we want to answer the question, can you earn a B? Now to earn a B, we first need to know like what score is needed, but let's not worry about that. Let's just figure out what is the range that we need to fall into for the final grade. So to earn a B, let's just go ahead and assume that an 86 will get you a B, or an 86 or better. So if we set up this inequality, we want to say we've got 3 grades already and 1 more grade unknown. So the grades that I have are a 78, a 78, a 79, and some last final test grade, let's call it G. So now to find an average of something, to average all these grades together, because there's 4 of them, you would just divide by 4. Now your score would need to be better than or equal to that 86 mark to get that B. So now go ahead, start combining, start solving, see if you think you can figure out what to do. So yeah, that means pause the video and try this. Alright, so all I've done is taken my numerator, combined these like terms, my constants, and now I got 235 is 235 plus G divided by 4 is greater than or equal to 86. Now here's where you have to be analytical about your problem solving. I can make my life a lot easier right now if I get rid of this division down here. So to do that, we could just multiply by 4, because 4 on top and on bottom will cancel each other out. So I have to do that to this side as well. So what I end up with then is 235 plus G is greater than or equal to 344. Let's make sure that looks like a G, not a 6. Alright, so now I have my variable added to a constant, and it's greater than a constant. So to get rid of this constant over here, it's positive, so we want to, that is right, subtract. I'm just assuming that you have all the right answers. So when I take 344 and subtract my 235, I get 109. And can you score more than 109 points on a test? Or actually greater than or equal to? No. So really the big answer to the question is no, you cannot get a B. If those first 3 grades were a little bit higher, you might be able to, but with the grades as they stand, you would be unable to get that B. So for inequalities that involve the word or, we have to keep them as 2 separate inequalities, solve them independently, and then graph both solutions. So I want you to take each of these inequalities separately, solve for the value of y, and then try to graph them. So pause the video now and try that. Alright, so now when we take both of these individually, hopefully you solved this on your own, We combine our constants over here, so we subtract 7 from both sides. That gives me negative 2y is less than negative 6. When I divide by a negative 2, notice we're dividing by a negative. So this inequality symbol will flip, which gives me y is greater than 3. We come over here, we do the same process. We get rid of the constant by subtraction. Now that gives me 4y is less than or equal to negative 8. We divide again, but we divide by a positive, so we just divide by 4. Then y is less than or equal to negative 2. So now I go ahead and I start graphing. Because negative 2 is further down, I will just go ahead and start with that. So I put a circle around that point. And is it filled in? Yes, because it has the or equals. Then I go up to 3. I mark that point. I circle it. Is that filled in? No, because it is not equal. So now since y is greater than 3, I go all the way up to the arrow. And since y is potentially less than negative 2, I go all the way down to the arrow. And that is problem 4. Alright, go ahead and try to solve this example problem right here on your own. Pause the video and take care of that. I am not going to walk step by step through the solution, but I will give you the answer here in just a second. So pause and solve. Alright, both of your inequalities have the or equal to. So that means that we will shade in both circles and then shade out the arrows because y is less than or equal to negative 2 or y is greater than or equal to positive 5. So now, what these interval notations mean down here? What's the difference between a bracket and a parenthesis? So the big difference comes from whether you include or don't include the point. So when we have the parentheses, it is not included. And when we have the bracket, it is. So what that actually means when we write it as an inequality is x, or whatever our unknown value is, will be between negative 2 and 7, but the 7 is not included. So negative 2 is less than or equal to x, and x is less than 7. So this is the interval in which my point can lie. So I can graph it by saying, here's my negative 2, here's my 7. I put circles around both. And negative 2 gets filled in because it is included. I shade all the way up to my positive 7, but I do not shade in its circle. When we think about graphing a single inequality, so I say single because there's only one inequality symbol, we have to think about the fact if it's just greater than or just less than something, it has no boundary. It has no lower or upper bound depending on how we write it. So if y is greater than 7, then I can do a number line notation of this by saying, okay, here's my 7. If y is greater than that, then y is anything above 7. So what that really means is if we write it in interval notation, is the 7 included? No. So we would use a parentheses and say 7, comma, now what's the upper bound of our potential values? There is none. So it's infinity because we can never reach infinity. And because we cannot reach infinity, we use a bracket because infinity is not included. Every single number up to infinity is included, but we can never reach infinity. That is all I have for 1.8 on solving our compound inequalities. Please download the homework and try it out. Get it until you are confident with your skills, and let me know if you have any issues or concerns. Thank you. Have a great day.